Recently, ENASA discovered a mystery object hurtling through space at 1.6 million kilometers per hour. Because of this, the object is traveling so quickly that it may be able to break out from the Milky Way's gravity and launch into intergalactic space. However, what sort of extraterrestrial Speedy Gonzales is this? Specifically, how could a heavenly body have accelerated to such a ridiculous pace, and how was it initially found? Are you familiar with NASA's Backyard Worlds initiative? While this study endeavor is looking for unidentified brown dwarfs and stars near the Sun in the Solar System's backyard, it is also keeping an eye out for the fictitious Planet 9, which is thought to be concealed deep within the Kuiper Belt. However, what type of intellectual background is truly required to participate in this thrilling galaxy hunt? None at all, actually. Backyard Worlds is a NASA-funded citizen science initiative that is primarily managed by volunteers. They only need to demonstrate that they have participated in a tutorial and have examined the fascinating objects that have already been added to the star charts. They are not required to possess any prior understanding of astronomy. Professionals' discoveries need not obscure amateurs' findings in any manner. In just 4 months after it was made publicly available in February 2017, the community search found its first direct hit, a brown dwarf located 111 light-years away. To give you a quick overview, brown dwarfs are celestial bodies that fall somewhere between stars and planets. These objects cannot induce hydrogen fusion in their interiors because their masses are less than 75 Jupiter masses. However, they are still heavy enough for deuterium fusion to start because they are also larger than gas giants. As we now know, brown dwarfs are not uncommon in space. More than 4,000 of these celestial bodies have now been located by Backyard Worlds participants. Additionally, the oldest and coldest known white dwarf with a dust disk was found by a resourceful amateur astronomer. But in the real sense of the word, Backyard Worlds participants have discovered something far more quickly. We now know of the presence of an object in the Milky Way that is moving at an astounding 1.6 million kilometers per hour, as NASA revealed in August of this year. But what causes this unnatural speed, and how can one possibly locate a heavenly entity moving so quickly? The Cosmic Blitzer Shot is a stunning discovery that was made possible by the Wide Field Infrared Survey Explorer, WISA mission of NASA. The Autonomous Space Telescope analyzed the mid-infrared sky starting in 2010 as part of this project. Reactivated in 2013 under the name NEO-WISA, the mission was shut down on August 8, 2024. Longtime Backyard Worlds participants Martin Katnick, Thomas P. Bickle, and Dan Castledon finally saw the WISE photos a while ago. A dim, rapidly moving object with the scientific designation CW-ISAJ 1149 had caught the amateur astronomer's attention. Katnick, who happens to reside in Nuremberg, was in disbelief at what he was seeing on his screen when he looked at the WISA photos. "I can't describe the excitement when I first saw how fast it was moving," NASA said of him. As we now know, this was not the case, but I was certain that it must have been publicized earlier. Following NASA's receipt of the Backyard Worlds community's hints, additional observations using a number of ground-based telescopes verified the thrilling finding. As a result, the citizen scientists eventually co-authored a formal scientific study that was printed in the Astrophysical Journal Letters. As was previously indicated, the Cosmic Rabbit's Foot is currently launching from our local Milky Way with incredible speed. In the end, however, CW-ISAJ 1149 is exceptionally remarkable, not just because of its rapid speed, but also because of its extremely small mass, which makes it difficult to categorize as a celestial body. Researchers must thus explore the realm of theories when trustworthy facts are lacking. It is possible that we are dealing with a low-mass star, which may also be categorized as a brown dwarf, if it is not continuously fusing hydrogen in its core. On the other hand, the celestial body would become an astronomical exception if this were true. This is because there aren't any other brown dwarfs that we are aware of that are going to abandon their home galaxies. Furthermore, evidence gathered with the Keck Observatory has shown that the object actually contains far less iron and other metals than would be predicted for stars and brown dwarfs, even though it is undoubtedly not getting into the iron on its path through space. NASA claims that the celestial body's unusual composition indicates that it is very old and may have been a member of the Milky Way's initial star generations. Why does the item move so quickly? Naturally, the specialists are limited to conjecture. One theory is predicated on the idea that CWISEJ 1149 and a white dwarf originally formed a binary star system. However, the white dwarf might have eventually taken so much material from its companion that it physically threw its stellar companion away from it when it burst as a supernova. According to a different explanation, the Swift-Gonzalez was initially a member of a closely related star cluster known as a globular cluster. In the end, the item might have descended into space at an unexpectedly high rate due to the chance collision with many black holes. In this case, a star could be thrown out of the globular cluster by the intricate dynamics of this three-body interaction. In the end, the experts now have to choose which of the two scenarios is more likely. The scientists will soon examine CWISEJ 1149 more closely in order to unravel this mystery and, ideally, determine what made the enigmatic object the quickest star in the Milky Way and a cosmic lead foot. The question of whether it can go any faster emerges given the speed that was just demonstrated. Yes, and notably so, since CWISEJ 1149 is merely a pitiful snail in comparison to the star's 471, albeit traveling at a respectable 444 km/h. The racing star in the Milky Way center travels at 76.4 million kilometers per hour, or 24,000 kilometers per second, which is unbelievable but true. Up to 88% of the speed of light is represented by this. Once more, the heavenly body's unique position allows it to travel at this pace. S471, the Milky Way's fastest star, circles Sagittarius AI, our core black hole. It only takes 7.6 years for the stellar speed miracle to orbit the mass monster in its entirety. In particular, the University of Cologne research team under the direction of Florian Pisker is responsible for the discovery of S471. They had tracked the orbit and velocity of a number of dim stars by combing through the observation data of two spectrographs at the European Southern Observatory's ESO Very Large Telescope. STU, a star near our central black hole that is exceptionally brilliant, was earlier spotted by the specialists. In addition to being the fastest star in our own galaxy, S2 was later used to test Einstein's theories on the gravitational redshift and the so-called Schwarzschild precession. However, S471 completes an orbit more than twice as quickly as STU, which still takes 15.6 years. The new record holder, however, does not continuously sustain a high speed. It only reaches its maximum speed of over 8% in the immediate proximity of the black hole, while its average orbital speed is only around 0.5% of the speed of light. In fact, experts believe that we might be dealing with a squeezer. That is, a class of star that has only been theoretically described thus far. Due to their very eccentric orbits around their supermassive black holes, squeezers are heated by the black hole's tidal forces as they get closer before cooling down once more at the distance. In fact, spectral studies have revealed that S471's thermometer rises to a respectable 10,000 Kelvin, or 9,700 C. In contrast, the Sun's surface temperature is around 5,772 Kelvin, or 5,500 C. However, the researchers also believe that intense radiation bursts in these stars are caused by significant tidal pressures. S471 would be the first known object to bring this possible class of stars from theory to reality if it turns out to be a squeezer as more observations reveal. However, the finding of S471 and 4 additional dim stars in the Milky Way's core also suggests that a huge population of unidentified stars may still be sleeping in the black hole's extreme region. The orbits of the newly discovered stars create two disks that are nearly edge-on at a 45 angle to the Milky Way's main plane, together with the stars already identified in the so-called S-cluster. On the other hand, the nature of this peculiar configuration is as ambiguous as the puzzle of how stars can originate near a black hole without being destroyed by its gravitational pull. But since immature protostars with dust cocoons have previously been discovered near Sagittarius AA, Scientists think there may be another, much smaller black hole sleeping in the Milky Way's core. This would prevent the extinction of the star birth clouds by opposing the gravitational pull of its more massive counterpart. To ensure that you never miss another video from us, please give us a thumbs up and subscribe right away. We'll see you soon from now on.